So we're going to talk about a couple of different things related to glass. We talked about contamination earlier and different applications in which to remove it, but there's quite a bit of different types of contamination. Dust, we don't see that so often, but occasionally we will see it from the boxes when the glass is shipped. Fingerprints on the glass is actually a line scale on this glassware, which is a real problem. A lot of times you'll see some water contamination, especially if the glass is shipped overseas where there's a lot of humidity on the glass. That becomes a bigger problem than glass manufactured domestically. One of the things that is not talked about very often is corrosion. So they put a little bit of metal in glass to lower the melting temperature, and that metal corrodes within the glass, comes to the surface. In addition to that, there's a tin spray that's applied to the glass as well, which oxidizes. So this is a microscopic image of what takes place onto the glass surface. And the contamination is moving up. This is about 4 microns. It's a very small, but it definitely changes the dynamics of the glass surface itself. And it can be a real challenge to remove. Normal washing isn't going to remove corrosion from the glass, nor will normal cleaning products. You can remove it with high temperature, normally around 1,000 degrees. Will remove the corrosion on the glass surface. And you can also cover it up with Pyrosil. The Duracoat and other lubricity coatings, which were mentioned a couple times today, are also a real problem. It's applied to glass. It does a great job in making sure that the glass doesn't scratch against itself, so that it maintains that clean look. But the problem is, of course, that it creates a hydrophobic surface, water hating, which makes it very, very difficult to print. You can overcome that lubricity coating at 1,200 degrees is the temperature. It's actually come up a couple of different times. I've heard many different stories about how to change the Duracoat coating or the lubricity coatings on glass. The standard flame treatment will change the coating itself. But as I understand, it's really more of softening the coating. And then after about 15 hours, that coating actually bounces back. And you can see that by doing water tests or dyeing tests on the glass surface. So talking about flame and being able to do that, the way you do it is when you test for flame treatment, and you take glass and put it in water, you'll see that it changes to hydrophilic, or that the water sticks flat to the surface and runs down. And that gives you an indication of the ability to print on the glass. If you wait about 12 hours after you flame treat and you put it back in water, the coating bounces back and it goes back to its hydrophobic state. This is one of the problems with standard flame treating, is that Duracoat actually pushes back against the ink that's on the surface of the glass. You can bring the temperature up to 1,200 degrees. That absolutely wipes out anything that's on the glass, corrosion, contamination, brings you to a completely clean surface. Obviously, energy costs are one of the problems related to bringing it up to that type of temperature. And the other thing is Pyrosil flame technology, which is a proprietary technology developed in Germany about 30 years ago. Some of the considerations regarding the Pyrosil is the application costs and the equipment. So some of the different things about the Pyrosil process. It's got 30-year history, so they've been doing it a long time, developed in the 1980s. It's really much different than standard flame treatment. You can see the picture here of the color of the flame. And what that tells you is that it's actually burning the Pyrosil within the flame. And what comes out of there is SiO2. Silica dioxide is what makes up about 50% of glass. So it really covers the entire surface of the glass, brings it back to its original state, and glass in its pure state is highly reactive. If you go to factories and you see flat glass being produced, you can really watch the dust in the air being attracted to that glass surface because of the reactive nature of glass. Related to some of the viscosity coatings, the Pyrosil will cover that up. We're only talking about somewhere in the neighborhood of 20 to 70 nanometers. So that's 20 to 70 billionths of an inch. So really a very, very small amount of Pyrosil that goes onto the glass or the surface that's being treated. It chemically changes that glass surface, and it's a permanent application. We can do the application of Pyrosil, go back 20 years from now, measure the height of the Pyrosil that was applied to that object. So once it's applied, it is permanent. What changes within the Pyrosil itself is the same thing that changes on any surface that attracts contaminants within the air, and that is eventually it's covered up. So when using Pyrosil, it's best to print within a few hours. You can go up to 10 or 12 hours without too much negativity of the application. But the quicker that it's done, the better off it is because you have the purest, cleanest surface at that time. Some of the different applications of Pyrosil, it's really used in many, many different industries. It's required by BMW and Jaguar in their automotive repair facilities to increase the bonding of adhesives. It's used in coating applications in the solar industry. It's used for improving bonding of silicones in the architectural industry when they put glass panels together in buildings. So there's really a lot of different applications for Pyrosil. It creates a pristine surface, promotes adhesion, increases the quality, and improves scratch resistance of the inks. The Pyrosil layer, the way it works is the chemistry is burned in the flame itself at about 1300 degrees, and then the SiO2 is coming out, and it's applied onto the surface in a very consistent format. It actually increases the light transmission on glass if it's done in a very, very precise way. We have to apply 30 nanometers to the glass surface 3 different times for a total height of 90 to 95 nanometers, and we got a 2% increase in light transmission. So we can actually improve the efficiency of solar panels with Pyrosil. Makes the glass actually clearer and brighter. There's a Pyrosil layer here. This is more of the application that we use in the print. This is about 40 nanometers height. We can increase that to 200 nanometers. Normally when we get to a certain height, especially in the print industry, the chains of the Pyrosil become weaker and they break off. So we normally, for improvement, and we can measure this with profometers, we normally like to keep the height below 70 nanometers. Normally somewhere between 50 and 60 nanometers is where we got our best adhesion. So the way that the flame works, it's a little bit different than standard flame treatment. And standard flame treatment, Steve did a real good job in explaining how that flame works and where the strength of flame is. Pyrosil, it's a little bit different. The accumulation of the particles happens a little bit further out in the flame. And what we need to do is to make sure that those particles are being consistently applied to the glass surface. So when we get too close to the flame, we're not getting enough of the particles to be deposited evenly over the surface. With the Pyrosil, we actually can have the flame quite a bit longer than on standard flame treatment, 6 or 8 inches. And the Pyrosil will go all the way to the ends of that flame and can wrap around the glassware. So it definitely has a little bit more flexibility than standard flame treatment in that we can have the burner be offset to the glass itself and pass it. And the flame will actually wrap around and hit the leading edge and the trailing edge and provide the same deposition as the sides. So it gives you a little bit more flexibility in the application. There's been literally tens of thousands of tests. This is actually an epoxy on metal. This was a salt spray test. Same applications for glass as well. But this is 10,000 hours. It's been used in many different applications in the automotive industry as well. These are glass applications, some plastic applications, scoring tests, and weathering tests have been done. Literally, I've probably been involved in more than 1,000 tests myself. The wettability factor, as I said, when the lubricity coatings create a hydrophobic surface, which is very difficult to print on in the first place. So almost everybody needs to have a standard flame process. Standard flame by itself does do a number of things to the surface of glass. There's waxes in the majority of the lubricity coatings anyhow that are removed just during the flame process. And you will get a hydrophilic or a water flattening effect that will allow you to print. And with the Pyrosil, increase the adhesion. I really like to use water. Water is 72 dyne level, so it's a very high dyne level. So if you, whether it's flame treat or Pyrosil treat, and take your container and dip it in water, you should really be able to see that water sheep off of the surface. We're recommended by a lot of our friends here, Ruco, Marabou, Sun Chemical, Norco, Nastar, Xerox. These are all companies that recommend the Pyrosil technology. Many of the companies that produce UV screen print, either on the private label or Pyrosil itself, offer equipment options with the systems. Many of the glass screen print decorators that are here are using Pyrosil as well. There's a number of different ways the application of Pyrosil can be done. We actually have a number of customers that are using these small portable units, and they set up a simple jig that uses a cartridge that screws right into the unit. And it has a couple of different flame options. The burner's pretty small, either 2 inches or side by side about 5 inches. These are set up on simple jigs with spinners. I mean, I actually have customers that have old record players where they have the burner set up to it and they're just handing the glass, putting it onto the record player or generator, spinners, all different types of ways. We have semi-automated systems that require handling where the glass is put on at every step and then removed off. And then we also have more automated systems. This one, this unit here has an accumulation table at the front and at the end, and the containers are put on and they're able to run down. One of the nice things about the Pyrosil systems is that we can adjust the flame and it'll be able to do multiple processes. So on this one, we're seeing the growler being passed through, but the same system can be adjusted so that you can use it for a tumbler glass or a shot glass and reduce the amount of Pyrosil and reduce your overall cost so that you've got a consistent cost per square foot. And that's Applied Surface Technologies. I did hear a question earlier about if the Pyrosil was a messy product, right? Somebody asked that. There is the SiO2 that is output during the process. You shouldn't see any of it on the glass. This is applied at such a small rate that you should never see it on the glass. There is a buildup near the burners of this SiO2, which is really, it's sand, it's silica. It's very lightweight. We have blowers that pull it out, but there is some accumulation. You just take a brush and brush it off the burners and sweep it up. So it's not a very messy process at all. Any questions?
Sean, how would you compare Pyrosil to the saline? Without knocking off any one of them, but what would you say is the direct comparison in terms of money-wise and
there's, at the end of the day, they're doing the same thing. It's a silica type of a process. The one thing is on the Pyrosil is that we can really nail down, like on the solar application example of being able to do 30 nanometers. I mean, if we're off by 5 nanometers, it no longer works. The cost per square foot on Pyrosil is really reasonable. We're talking about less than a penny. I know that there's other products out there that are also incredibly reasonable, but you can get on the automated systems where we're taking a liquid, evaporating it, and then running it through the burners. We're considerably less than a penny a square foot.
Would you say your process is better than the saline material, or?
Do I like it better? Do I like it better?
I want to hear from you. What do you think?
I mean, I can tell you this. I mean, we're recommended by all the ink companies. You know, almost all the ink companies have our test units or our tabletop units. I've gone to many customers with the ink guys doing testing. You know, I don't have that much experience on the silenes. I do have customers that have the silene process and Pyrosil, and they're running them in sync. So if it was that big of a problem, you know, they would be being replaced by the Pyrosil. So I'm not necessarily of the technical advantages on the other ones. I know that Pyrosil is incredibly flexible to be used, and it has very low cost.